Hello again, everyone, and welcome back to Enterprise Linux Security. I'm here, as always, with Joao, and we're going to talk about DevOps today. How you doing?
All good, Jay. Thanks for having me. And yeah, we're going to look at DevOps today. I realized we had gone through some concepts that directly or indirectly touch on DevOps, but we never actually went through the methodology and
Yep.
how it relates to everything. So I think it should be a good topic for today.
I think so too. It's a foundational thing, like you were saying,
Yeah.
because it's not a direct security topic, but it also is because security is a big part of DevOps, as it is everything. But there's going to be other things that we're going to talk about, which is going to require that we've had a discussion about DevOps. So we have an episode to point people back to. And that's what it is today. And DevOps is one of those inescapable things when it comes to IT, like that it just comes up. It's a good thing. And,
Yeah.
I've done it, which we'll get into. So yeah, should be a great podcast.
Yeah, it's basically, well, we can't exactly say that it's something new. It's been around for since 2013, 2012 was when the concept started floating around.
Yeah, that's when I
And
first heard of it.
yeah, and it's basically just a different way of looking at operations and development and how to get the best of both worlds.
So how would you describe DevOps if you were to define it? That's a hard one, I know.
Yeah, it's a very hard one. Everybody has a definition for it, and nobody agrees exactly on all the little details of the thing. But basically it's a way to offload some of the tasks from operations into developers. And the reason this is important is because previous to DevOps, the development cycle, let's suppose you have a company that has 10 or 12 in-house developers that they are building some tools that are used inside that company. They would code, they would develop new releases, they would then have to send the builds to the operations teams, which would then have to deploy them on the servers, and then something came up because it always does. They would have to go back to the developers, and this back and forth, it takes a long time, and it was slowing down the development cycle, and it was dragging down on the operations because they were only doing this instead of doing other things. So yeah, people realized there had to be a better way to do things, and that's where the concept for DevOps appeared and where it came from. It's basically a methodology for development and operations in modern IT.
Yep, that's a good one. So I'll give a little bit of background in my experience because I've done this before. And that'll also, I think, help. It'll piggyback off your description with the real world scenario. So I is actually my first Linux job ever. I've been using Linux since 2003, but I was doing Windows admin. That's where I started life basically. And this job came up, Linux system administrator. I applied for it, got it, which was really great. Started working for the company. Started hearing about DevOps. The word was starting to come around, and basically what the company was looking for, they were I want to say 10 or 12 developers, and very, very smart people, really awesome people. And they were developing a GPS solution, which was very complicated. And so they were doing their thing. And before I started, they would have one of the developers be elected as that week's IT person to build servers and provision things and maybe write automation code or whatever. So that person would have to stop doing their day job or their normal job and do this other thing. And then they just pass that baton around. And needless to say, it was very distracting because, they're developers and each one of them were very talented Linux people in general because they just knew Linux backwards and forwards, but they became developers. That's where they transitioned into and where their interests were. And they didn't want to be stopping their projects of what they're working on to go do the IT thing or the server build thing. So they wanted someone to come in and be that person for them. And that person ended up being me. So my job title was Linux System Administrator. And then the buzzword DevOps started to float around. And I remember asking my manager, I'm like, yeah, have you heard of DevOps? Like, what's your opinion on that? He says, yeah, that's what you're doing right now. Actually, that's what you're doing. And I'm like, oh, really? He's like, yeah, that DevOps, that's exactly what you're doing. So basically what my job looked like is we had, it was a Debian shop mostly. There's a couple other distros there, but they would need a server built for a test or compiling something, or, as some part of the overall process. I helped manage their file server and backups and networking and pretty much all of that, software-defined networking and regular networking. And I was the go-to, like I would be in the meeting in the morning. They would talk about what phase of development is in. And they would correlate that to what my action items were to support them and give them what they need to get that done. And it was a ton of fun because I felt very appreciated. And I was, because every single one of these people, they very much appreciated me because I didn't have to stop being the developer. They could just continue doing their job, and I would take those tasks off their plate. So it was a really good experience. And I know DevOps, there's variations of this, like you were saying. I mean, it's hard to explain because if you ask 10 different people what DevOps is, I think you'll get 10 different answers. But what's consistent is infrastructure as code, building infrastructure for, to support the development team. And of course, they put other things on your plate as well that may or may not be related, but that's how it goes.
Yeah. There is one. Basically, DevOps came along. It was like the perfect storm. You had containerization coming up. You had strong virtualization background on lots of sysadmins at the time. Automation was taking off. Developers were working on faster cycles when we were doing agile or something like that. So they had this 2 weeks period where they would do development and then produce a build, and then they went to that build and going out in production and getting it in the hands of customers and all that. So basically, it was the perfect storm. You had all the ingredients for a shift in how things are done. IT traditionally has this very big issue. It's very quick at adopting new technologies, but it's very slow at changing processes. And DevOps came along, and DevOps changed the mindset, basically. So some of the tasks that were traditionally done by sysadmins, like preparing systems, like you just mentioned, and all that, could now be offloaded to the developers by using, for example, Docker files. So the developer could write exactly what he wanted to be on the system, and then Docker would provide that. Specific versions, specific modules for Apache, for example, or for Nginx or whatever. And they had a way to actually get immediately whatever they needed. They didn't have to pass that stuff along for the sysadmin and then wait a few days or a few weeks to have that deployed and then do the testing, and then it didn't work. They needed something else. So it lets developers be more agile at what they do, be quicker on their turnaround, and produce results faster.
Yep.
But again, this is standing on the shoulders of giants. The way automation is used in DevOps and the way that containerization is used in DevOps, it's basically having all those things being created through code rather than through human interaction, basically.
Yep.
If you want to go to a more sinister route here, it's the machine doing more stuff simply through the code rather than human intervention.
Yep. And there's, I feel like with DevOps, the individual technologies stack really well. Because, when I started, probably the same for you too, but it's like there was none of this, right? So we get a server in the door, we rack it, run it for a couple of weeks, just make sure it's not going to fall over. There's no hardware instability or whatnot. Getting the server in the door could take months. We get it in the door, we provision it, we install the OS manually. Maybe Norton Ghost or CloneZilla or something might be used to automate at least part of that, but that's just an image thing, not automation. And it took a long time, and it was very manual. And then when Puppet came around, I don't even know if that's the first. It's just the first I've heard of when it comes to automation that allowed infrastructure as code. Like, what is the end result that you want to achieve? And you write the code to get your systems from where it is today to its end result with no human interaction, like you were saying. And that's the goal of the automation.
So basically, the role of the sysadmin changes, like you just said. You're no longer deploying the system and installing everything and getting it ready and then accepting the builds from the developers and deploy them yourself as a sysadmin on that system. You prepare a basic system, you deploy a containerization system there, for example, Docker DE or whatever, and you give the developers access to it, and then from the developers themselves from their workstations, they can just say, okay, I need the new container running this, this, and that, and it happens. It's like magic.
Yep.
And that's the real magic behind DevOps. It eliminates a lot of the waiting time there. It facilitates things. It makes things happen faster. And along came the cloud, and this just exploded, because now you don't even have to deploy that on premises. You can just get another cloud instance somewhere, and the same technology, the same stack applies there. You're just running containers in a different place.
Yep.
But all of that comes from this different approach and this different way to look at systems and new servers and all that shifted from a traditional point of view to this DevOps mentality. And this was the biggest evolution in the past few years.
It really is.
This was probably bigger than the cloud itself. This new approach to computing, because it uses the cloud, it exploits the cloud in a way that basically no other methodology or no other way does. And yeah, this might be a very wild assumption, but anyway. You're running your own company with a DevOps mindset and a few servers in the cloud or a cloud provider or something somewhere.
Yep.
You basically need less people, the job gets done the same, and everything is automated, and your developers are happy, which is something that traditionally doesn't happen, because they are always annoyed that the sysadmins that they never do their job properly.
Right.
Yeah. I'm sure you experienced that as well.
All of it. Yeah. So some of the challenges, I guess it might be a good idea to talk about some of the challenges that I went through before the DevOps movement, and to some extent after, because, not everyone adopts it all the way. But let's just say you have a team of system administrators, and they build servers, they build Linux servers. And what a challenge has often been for me at the companies I've worked for is, depending on who built the system, things are in different places, right? So you might have this one person use a certain naming scheme for mounting storage. This other person uses a different naming scheme for mounting storage, or the folder names or whatnot. And, so you'll find yourself using the history command in Bash quite a bit, because you can find out what the previous person did pretty easily by looking at the Bash history, which is especially if you're starting at a company brand new to the company, like the Bash history is just a gold mine of every command that was previously run, as long as I didn't clear it. But everyone would do things different ways. So when I'm fixing a server, it's like, okay, where's the extra storage directory? Where's this? Where's that? I don't know. I have to look for everything because there's no consistency there. Worse, it's like, oh, we need a virtual machine for this endeavor. Let's submit a ticket, and I think it'll get turned around in a week. We'll probably, maybe a week and a half if there's some back and forth, but we'll just submit the ticket to the IT team or system administrator team or whatever, and have them build the VM. Then they'll get back to us when it's done. We can't do anything until then. We're just going to freeze everything until we get that VM, because there's a process for building things that's got to go through the proper channels and whatnot, and that could take some time. So that slows things down. So that's another problem. And those are just two off the top of my head, and there's so many more issues that this tries to solve.
There is one that always drove me nuts, is when you get to a developer, they ask for a specific system. Again, not using DevOps, using traditional approach. And okay, I need a web server that has these specific versions of this component and that component and all that. And this is working fine in my machine. If you deploy that, those exact versions, it will work on the server. Mm-hmm. And then it never does. No. Either because they got the bitness wrong, it's not 32 bits, it's 64, or because it's the different language, or because of some other crazy things that can interfere with this. And DevOps brought standardization to this. If they deploy a container on their machine and the container is running, you simply take the Docker file that describes that container and you run it on the server, and it's exactly the same. You avoid much of this complication, of this complexity, and it immediately solves those issues. And those are the ones that will leave a sysadmin scratching their heads, because the sysadmin on their end, they deployed everything that the developer asked for, and it's not working. And then they'll have to spend hours debugging that, and the developer will keep annoying you. Oh, this is working, it's your fault, and no, it's yours. The requirements are not right. And this back and forth, again, this drags the whole process. This makes everything go slower. And DevOps fixes this. It completely avoids this type of situations.
Yep, it really does. So to break it down a little bit more, each individual component, because I mentioned that the technologies in DevOps stack really well. I think that's kind of like the secret sauce here. So you have the platform first, which is where your servers are. And for me, at the DevOps job I had, we were running virtual machines. We were looking into containerizing later on. That was a goal. It was never achieved, unfortunately, because the corporate ownership of the company pulled the plug on our company. So unfortunately, we had to shut our doors. But I feel like we would have totally made it to containerization. But I just wanted to mention that because containers are going to be very common, probably the most common, but you can still apply the DevOps mentality to virtual machines if that's what you run, if you haven't containerized things yet. So you have the platform. The platform could be OpenStack, it could be Docker, it could be Kubernetes, Google Cloud, AWS, DigitalOcean, whatever. It's the thing where your servers are running, or where your servers are running, where your infrastructure is. And you have a team of developers that are developing a product or some code. They're writing code, and they run the code on the platform, and you as the DevOps person will help create the code, automate it. If it's still using virtual machines, maybe you'll spin those up or automate that too, because you automate all the things. And when it comes to automation, this is the beauty of it. It's just so organic and so great how well this works. So you have infrastructure as code, which we've discussed, which is an automation solution. It could be Puppet, it could be SaltStack, it could be Ansible, Chef. There's a number of these. Yep. And that defines getting the software installed and everything in the right place, and removes human error because there's no human error because it's automated. There's no variance here. It's always the same. But going a level underneath that, how do you build the containers, or how do you build the servers? Like you have the automation for installing everything, but you have to have something to install the stuff onto. You need a server, you need a container, you need something to run it. And then you have a technology, for example, Terraform, right? Because Terraform can make servers exist. It can automate the creation of virtual machines. It can automate the creation of containers and all these different things. So you could say, this needs a 4 gig virtual machine with 2 cores, or a Docker container with these specific constraints. You define that. So now you have something to install your software on. But if you go a level underneath that, especially if you're talking about virtual machines, I mean, the last thing you want to do is install the Linux distribution from scratch every single time, right? You don't want to do that. So then there's technologies like Packer, for example, that automate the creation of the images that are used. So basically, you can automate every level. Like Packer creates the image, Terraform grabs the image, makes the servers exist, and then your Ansible, Chef, Puppet, whatever it is, grabs that server, makes it into a web server, database server, app server, whatever its intended target is. And it's just so beautiful when you see everything get created from like the bottom layer moving all the way up to the top.
Absolutely. And this ties into something you said before. It's interesting, the concept of a desired state. Rather than installing from scratch and starting to configure it, you begin with how you want the server to look like, what you need in the server. And then all of those tools, they will work together to get the system to that description that you give them, that desired state that you want it to be in. And this changes things all the way around, basically. So you're no longer deploying individual applications, you're no longer deploying individual configuration changes. You just pass along the desired state that you want the system to have, or the container, or whatever, and then those tools will work together to achieve that. And like you said, that gets you standardization. That avoids the variance. That avoids, like you said, the differences from one person deploying to another person deploying a system.
Yep.
And it really helps when you make that shift. And I know this isn't easy. I struggle a bit to transition from one mentality to the other as well. When you go from one mindset to the next one, it takes some effort to get there, because you're used to doing things in one way. You're used to deploying your servers and tweaking them to no end and getting everything out of them. To avoiding all that, you basically no longer touch the systems at any point of the process. You just ask them, okay, give me a system with these characteristics, with this memory, with this hard disk space and all that, and it happens. You wait a few seconds and you have the system like that. It deploys the images, it pulls it from somewhere, and yeah, it really makes life easier if you work with that approach rather than the other one. It's an actual improvement.
It's across the board. It just is transformative because, it does require a different mindset, context switching. But once you get there, it's like, I would have been doing all of that manually, and that would have taken a lot more time. And everything is better. And now that things take less time, you could be more creative. If you have a really great idea, this will really help the company if I implement this. I don't have time to do that because I got to build all these servers manually. Well, now I do, because I don't have to do that manually now. And it's such an improvement over the course of the entire company, because that time that you save, there's this saying, like, you don't want to automate yourself out of a job, and that's totally not true, because you're automating yourself into more of a job, because you can use your time to do more with it than you could previously, which means you're going to have more bragging rights at the end of the year about all the things that you've accomplished that you've actually had time to do.
Absolutely. And it also helps with another small detail that we've mentioned on previous episodes of the podcast. We always talk about setting up a testing environment. Guess what? Yep. Using this type of technology, you just get it. It's basically for free. You have a production deployment and you just copy the files. Okay, now give me this, but on a lab environment, on a different network. Let's define a new network and let's deploy these new containers on that network, and that's your testing environment. And it's exactly the same as the production one. And again, that makes life really easy. For all the people out there that have always struggled to getting a testing deployment, to have a lab, to try new software, to try new software tweaks or whatever, this is a game changer again. It really makes life easier, like I said before. It's the type of thing that you really should be playing with. If you're not doing it at work yet, you probably try it in your home lab, try to see how it happens, try to understand the new approach to the process. Try to get your head wrapped around that, and you'll see the benefits really fast.
Yeah, and also, at least in my case, you might find yourself using the tools in places you didn't think you would, because it's not just the stack. There's other areas that the same tools can benefit. So the company I was referring to earlier, which is going to probably continue to be a really good example here, they were Debian on everything. Debian. No judgment. I like Debian. But the idea was, the servers are running Debian. Everything is compiled there. So they would recommend everybody run Debian on their laptop or desktop as well, which they did. But if someone wanted to use a different distribution, they could do that. But if it didn't compile, the first thing they're going to do is blame the fact that they're not running Debian. So, and this was a problem because, some people insisted on running Gen 2. We had 2 Gen 2 people out there, which was fun. An Ubuntu user, a couple Debian users, Mac users. And what I ended up doing there was I created a container, a Debian container that all the dev tools on it, everything that was, tested at the versions that they're tested. And I released this container to them. So regardless of which OS they're running, and there's still variances with, containers, different operating systems I won't get into. But for the most part, they had this Debian container, had all the tools built in. They could, pull the container down, use it to develop things. And it didn't matter anymore if they were running Gen 2 or Arch Linux or whatever it is they're running, because they had this Debian container. If they could run a container, they could run the dev environment. And you could argue it may not be as fast, but it really worked for them and allowed them to use whatever OS they wanted. And they had this development container that was the same for each person that was writing software.
You mentioned that it wasn't as fast. It was about 2010, 2009 that we stopped worrying about performance.
Yeah.
Basically, as an industry, we were always looking for more gigahertz and faster faster systems. And around that time, we just stopped. We stopped worrying about bragging numbers around speed, because we would get more cores and all that. So that hides away some of that. You won't notice the performance hit anyway. On
Yeah, I think
day-to-day
one of the
work,
issues was Mac at the time, and this might be true now, and I think even Windows, although we didn't have any Windows users. It's just like the implementation of Docker isn't quite the same on Mac as it is like on a Linux distribution, for example, because there's like an emulation layer. I don't know if that's still the case now, but I know that did introduce some bottlenecks there. But overall, it was a success. Like they were very happy that, oh, I can just run whatever I want. Okay, it's as long as I have access to Docker, then I can run whatever OS I want. Doesn't matter. Pull down the container, and I can make changes to the container. Then everybody can pull down the new version and get the changes in there. So if we notice a bug, we can fix it. Everybody benefits from it. So that was a really good fit.
Mm-hmm. Yeah, it is. It really is. And
Yep.
for people who haven't tried it before, it's kind of hard to describe. But
it is, yeah.
If you're doing things traditionally and you find yourself struggling with version incompatibilities between different applications, or needing, take for example Java, if you need one Java version for one application and you require a different Java version for another, and you're messing up with environment variables pointing to the Java binary for this and for that and for something else, look at containers. It's a pretty good solution for your problem, and it has a smaller learning curve. It's not as steep as having to fix all the issues with different Java versions all over the place. Right. And it will get you the applications running. You'll find your solution, and you won't spend as long doing it. And I don't know, just talking about Java version brings Tomcat, which was another thing that I spent a long time trying to fix issues on.
Yes.
Yeah, and it was supposed to be easier and more compatible and all that, but it never was. There were always dependency issues and things that you had to fix. And now you can just get everything inside of one container, and that solves the problem. That deploys the application, and everything runs smoothly.
Yep, and it helps with the works on my machine argument too, because you know, that I hate that argument so much, because it's like, okay, great. Congratulations, it works well on your machine, it doesn't on mine. So clearly there is something missing here. It should be the same, you know, no matter what. Containers, you know, you have everything packaged into, well, a container. Everything you need is there. The versions, the config files, everything you need is in that. It's almost like this big box. You just stuff everything in it. That's all the things that are required, and blast versions of things and whatnot. And then you have this thing you can deploy that is, as long as you do it right, not going to run differently depending on what the underlying OS is. It's going to be the same for every person running it. And that's what you want, because anytime that argument starts, well, it worked on my machine, oh boy, here we go again. I don't want to have that.
Right, send me your machine and let me test it there.
Yeah, just mail it right over. Can I virtualize your machine? Can I just get an image of the hard drive and throw it in the
I'll
cluster
just
there?
rack it downstairs on the data center. And this and DevOps also works with another issue that IT teams sometimes have. Sysadmins traditionally did not want the devs to touch their systems and change settings on their own and do their changes, and the devs didn't want the sysadmins to muck around on the code and find issues and pointing them out and all that. And this neatly separates things. So the sysadmins prepared the platform, the developers deployed their containers there, and this completely sidesteps the problem. It doesn't fix the problem. There will always be silo problems and communication issues between different teams, but it no longer matters for getting the work done. The work gets done regardless if there are issues or not around that. And it's another of the advantages of around DevOps.
So the way that it, just to kind of, one of those scenarios that it could play out as, just to kind of paint the overall picture, you have a team of developers, they're developing an app, and let's just say they have it in a container, it's working fine. But now they're doing a version 2.0. There's some new features they want to implement. So they have traditionally and usually they'll have like a testing stack. They could just spin up a server or a container, you know, destroy it, build it, destroy it, build it, destroy it. So as they're going through their code and code reviews, adding code and adding the features, testing it out, they test it out they could be testing on a Docker container on their own machine. And once it's working, they do their code review, eventually everybody on the team, yep, it's good. We've tested it. It's ready to go. So then at that point, that container template or Docker file, container image in a repository, whatever it is, that's the final step. They can either run it on production if they approve it to be that, and if they have access to production, but if they don't, then they could ship that container to the system administration team, like, it's blessed, this is the container, this is the day we want it to be released on, and it's ready to go. So then they could schedule that implementation. And it just gives you this ability to where they're not like asking the system administrator over and over again, like, I want a VM. Okay, thank you for the VM. I think I need 1 more gig of RAM because it's not quite working. I need another thread. Oh, I just maxed out the hard drive here. Can you add a little bit more space? And each one of these individual things could be a ticket that you have to submit and then wait for it to come back. But then if everyone's developing against this environment, they could themselves get it right and then tell the administrator at the end of the day what they found is required to make this work, give them the image, the requirements, and it just simplifies everything. And the automation has effects beyond this too, because even after the product is out, a security vulnerability comes around and, oh, I have like 1,000 containers and we have to like update it, this package and all of them. Oh boy, that's going to take a long time. Oh, it's automated. We just make the minimum version, this patched version after we test it and roll that out. And now we don't have to touch all these servers or VMs or containers, whatever it is. And that allows you to get the security fixes out faster because it's part of your automation. I even at one point had a security playbook that was all the requirements in there with like comments on why it's required, what CVE it fixes. And all I had to do is just pop it in that file, deploy it. And it was great.
And it also helps beyond security, it helps also on capacity planning. If your initial deployment is just for one server and the application is running fine, but then you see that you have too many users and it's slowing everything down, you just spin a few more containers with the same Docker file, with the same image, and you get it behind the high availability, say HA proxy or something like that. And there you have it. You just increase your capacity with minimal workarounds, with minimal fuzz, and basically the developers themselves can do that. They don't even have to worry to get in touch with the sysadmins. And yeah, that's the real magic behind this approach and behind automation itself. But when you consider it within the scope of DevOps, that's the real magic.
Yep.
I can't stress this enough. It makes your life easier. It really makes your life easier.
It makes software deploys a lot easier in other ways too than just deploying the software, because you could be a shop where, let's say you get on average 100 downloads a day. I don't know, I'm just making up numbers here, which is fine. Your servers can handle this. But when you release a new version of your product, then your needs just quadruple. Like everybody's got to get that new version. So now these 3 containers, 3 servers, whatever it is you have, it's not enough. You need more. You don't want to manually create more servers, although some do, because you're going to need more servers when your product really reaches a new version. But you're not going to need all those servers all the time. You just need some servers to handle the load that's going to come from early adopters. And one of the things that it allows you to do is auto-scaling, which is kind of like horizontal scaling. Let's just say you have 3 servers or 3 containers, and that's enough for you. They're maybe 20, 30% full or used up. But when you release a new version, this is just going to max them out. You could have it detect where the CPUs are kind of having some trouble here, or the resources are kind of starting to be constrained, and then it'll spin up another container and another one or another server, depending what you have, but probably a container, and then spin up more automatically to handle the load, to spread the load. And then when the load dies down, everybody's downloaded it, it's a week has passed and it's okay, it's settled down. It'll just start deleting containers or servers back down to a minimum number, which could be 3. And you could set a maximum number so you don't have like 10,000 containers and then a major bill. You have to have a limit there, right? But you could set it to grow. It's like Elastic, which some cloud providers use that term Elastic, where you could just stretch everything out, just build some servers, remove servers to kind of organically have your infrastructure handle what's coming at it, and automating the scaling of things too, which is something that can make software deployment a lot easier because you don't have to manually create a bunch of servers and be ready to hit the start button and adjust your load balancer and all these things at the right minute and DNS entries and all these things. You can have that automated, which will really help a lot.
Yeah, and that's one of the great benefits of the cloud. It's giving you the capacity to respond to those quick spikes in demand. You just spin another instance, you just spin another container, another VM, or as many as you need, basically. And your infrastructure will handle it, your automation tools will handle it, and everything will just keep responding. And knowing all this, it's amazing how some, I won't name game publishers, for example, still won't do that properly when they launch new versions of DLCs or expansion packs or whatever, and you have these major queues and you have the issues on launch day and people are waiting hours to log in. But again, I won't mention no names to avoid the
Yeah, I want to so bad. I mean, I play a lot of games. I'm more of an offline player myself. But online games, I've seen it time and time again where they just can't handle the load when people are buying it on release day, and it's like, how is that still a problem now? Because we have the tool to fix this. Like,
how is that still an issue?
Right. It makes no sense to me at all. And even and I said we're not going to name names, but I'm about to. When anytime I hear like Apple is releasing new products, it's like their store's down. Literally, it's down. They shut it down. It will be back soon, or I don't remember what it says. And then it comes back with a new version, and I'm thinking, have they ever heard of like time to live and like DNS flipping to another server at the right time? Like, but I mean, there's probably more reasons than that, but I don't know of any other server or any other company that everything goes down and then it comes back up. But we've solved these problems many, many, many times, especially with game companies. It makes no sense. Like, I can't even remember what game it was lately. It was even in the news that they had a botched launch. One game in particular can't even be played at all right now. Like after release, you can't play it. There's no way to play it. And they don't even know when they're going to have it fixed. It's like, I don't know. Maybe they need to watch my YouTube channel or something before they roll some of these out.
Yeah, like you said, these are solved issues. They should no longer be an issue, especially at this level. At the level of these companies at this size, of this capacity, they had to know this was going to happen, and it's poor planning if they didn't. Because it happens with every single expansion, it happens with every single new launch, and again, this is a non-issue. It's only happening because they don't take the necessary steps to actually correct it.
Right. I've had situations, it does happen a lot less often, where a new piece of software comes out, even a Linux distribution comes out. I remember earlier in my career when a new version of Ubuntu came out, I would make it a point to download it like a week later because I'd be like, I'm not going to be able to get it downloaded. I would just end up using torrent, which is better anyway. But literally, it's just like I can't download it. Like I download it or I start it, and then it just times out somewhere in the middle. I can't get it down, and then a week later, when more people have successfully downloaded it, I'll go in and I'll grab it then. And I don't run into that anymore. I know that's not quite the same thing because we have mirrors and whatnot, but software distribution, even though a lot of companies still kind of do it wrong, it's still a lot better because I could tell that I have this problem a lot less often nowadays, which is really great.
Yeah, and something that also helps that is the CDNs, the content delivery networks. It also alleviates that problem by local caching at specific points in the network. It hides away some of that problem by spreading the load more and more. And probably why you don't see that issue happening today, basically. Even on the other side of the fence on Windows updates, a few years ago when they launched getting them on patch day, it was almost impossible. The download speed would be atrocious. So you would wait hours for the 2 megabyte patch or something like that. So it wasn't an open source or a Linux specific problem, It was just a constraint of the network and the constraint of resources. But with this scaling that we have today, that no longer has to be an issue.
And I feel like there's just so many topics that we've covered that because we're covering the greater DevOps itself, but they're within it. I mean, we could have entire episodes dedicated to automation, dedicated to containers, dedicated to load balancing, and every single thing that we mentioned is probably an episode of and by itself. But this is stuff that we
Absolutely.
have to talk about. But then there's also DevSecops as well, which kind of brings us full circle into the security side of things. And that I think that could even be something possibly that could be an episode, but at least we should probably talk about it in a nutshell, I think.
Yeah, I really think we should spend an episode on DevSecops.
Yep.
Again, it's another buzzword that came a few years after DevOps, and it's basically integrating security concerns into the DevOps pipeline. When you're building the images, there should be some concern into how secure are the images that you're pulling. Have they been tested? Have they been patched? Are you using the latest versions of whatever you're pulling? And DevSecops touches into that. It has mechanisms in place to check versions that you're pulling, to make sure that the images are signed, for example. And then at other stages, it's using tools that do static code analysis, looking for bugs when the developers are creating the code.
Yep.
It's testing the applications on a secure environment before they go into production. And basically, it's automating all of these steps, not just the development and deployment and productions phases and creation of the containers and all that, but adding security layers and security checks that happen at specific points in this process.
Yep.
And that's DevSecops in a nutshell. Of course, each of these specific operations, we could talk about it in much greater detail, but yeah, probably today we won't have the time to get into that, and we should get in a later episode. But yeah, it's another of the buzzwords around DevOps.
Another thing I want to make sure people are aware that exists, and as part of what you were saying about DevSecOps, is governance. And there's entire solutions around this, or you could just roll your own. But essentially what it is that you give your developers or DevOps or whatever, your people, access to spin up their own infrastructure, and they will do that. They will absolutely do that. You give them that power, they will do that. And you also want to make sure that they don't do anything that you don't want them to do. So for example, let's just say you have, I don't know, some data that you want to put in a VM or a container and test some things on, or a database server is probably a better example of this. And it's company policy, as it should be, not to make this publicly available at all. Like you could just, like LAN access is fine. You could just update your etc host file locally to kind of trick your system and develop or whatever it is you do, and you develop it locally. But you don't want it publicly available because, you haven't vetted the security yet. You haven't really done your due diligence there. Governance is kind of like having a way that checks what people are doing so that they don't make a database server publicly available, which is horrible. But sometimes a cloud provider could have that as its default sometimes, where it's just by default open to the internet. And, then you could have a system in place that says, oh, well, hold on. No, you can't do that. And this is why, and this is what's going to happen. And you could do it in a way where it lets them do whatever, but it just, lets a manager know that something was made publicly available. They could bless it. Yes, I approve that. Or no. Or you could have it set up to automatically correct it. In the case of a cloud provider, you could have it set up to where they make a database container publicly available. And I think I'm going to use that example a lot. It'll actually make it not publicly available as soon as they create it. It'll just go in after them and close the port or whatever from being accessed to the firewall. And because if you don't have a system in place to where you have, it's not that anyone wants to break rules on purpose. That's not what this is.
Yeah, it happens.
There's so many things you got to pay attention to, and it really is helpful to have a system in place that will say, yeah, by the way, you can't have this publicly available unless you have a blessing or whatever, and we'll freeze it, pause it, whatever for now, get the approval and whatever. So that way you don't have to worry that one of your people might accidentally make something publicly available, and then you end up on the news for all the wrong reasons. You definitely don't want that.
You're talking about leaky S3 buckets, I'm sure.
That's one of the things too. Yeah, that's on the list.
But another important thing that is tested, and there are automated tests for this, is not including credentials into the Docker files or the configuration files that you're adding to the image. And there are tools that will check your deployments and make sure that they are not there, and they will warn you before making it publicly available, because it's like pushing your passwords to GitHub inside of your project. You should never do that, obviously.
Oh.
And if at this point you're still wondering, but why won't I be able to, or should I be able to do? Yeah, you shouldn't be able to do that. And if you're still wondering, maybe you shouldn't be doing sysadmin job.
Sure, at least reading up on some stuff.
Yeah. But yeah, what you mentioned is totally part of this. It's part of the DevSecops mindset. And it's another set of rules and checks and balances, like you guys like to say in the US. It's about validating what you're publicly making available, what you're uploading, what you're getting out there. And it's how to get things done securely, basically. It's the whole goal. And all of the steps will be audited in some way or another by hopefully automation tools and automated mechanisms. But if by nothing else, then somebody from the security team actually looking at the configurations that you're sending and looking at your settings and all that. And yeah, you don't want to be the guy that gets that database open somewhere.
No, it is not. I've seen that play out a few times now, and the people were not.
It's always in the news.
Yeah, it is. I mean, in my case, I've stopped my fair share of those before that happened, thankfully. But it's like, yeah, everyone starts out somewhere. I get it, but there still has to be checks and balances. I think the only thing I hate more than API keys, or maybe not as much, it's debatable, but on that level, I hate when you have API keys that end up leaking out or being thrown in Git or whatever. But the other thing I hate almost as much, if not more, is when someone makes the mistake of like emailing the private key to their SSL cert and clear text over email without any password or encryption or anything. And especially as a managed service provider, where if I'm hosting for other people, it's like, yeah, I need you to send me your certificate, right? But then I've trained myself to say, I need you to securely send me, and they still probably won't. And I stress to them, don't send it in plain text over email. And then they'll do it anyway. And it's like, you have just invalidated the SSL cert for your entire company. You're literally going to have to roll out a new cert for everything now. It's horrible, but it happens. There's all these different things that you really shouldn't do that people learn the hard way.
Yeah, absolutely. Look at PGP security for
Yeah.
if nothing else, just look at pretty good privacy and set up some secure email client or something to send this type of information.
Yep, absolutely. It just got to just always err on the side of caution. That's I think the moral of the story altogether when it comes to security is there's no perfect security, and mistakes will be made for sure, but try to make it as few as possible and try especially not to make the really big mistakes.
Yeah, you shouldn't make life easier for the bad guys.
Right. Yeah, and they will use it. If they find it, they will use it for sure. We could probably have a whole episode on what not to do, which is probably not a bad idea, actually. Just don't do these things, especially. It's probably another one we'll probably need to do. So
I don't know. I tend to be very preachy about this stuff, and people don't like it very much. But yeah, over the years, you pick up lots and lots of things that you should never do, and getting those out there might help somebody. So yeah, it might be a good idea. It might be a good idea.
Yeah, so there we go. Live, we're not live, but we're recording this and coming up with ideas for future shows, and you guys are hearing that play out in real time. That's pretty cool. But was there anything else you wanted to cover on DevOps? Because I feel like we will need to have some follow-up content on this. I don't want anyone to think like this is it for the DevOps, but
we barely scratched the surface. We just described some of the aspects of it, but yeah, we'll probably revisit this. If not on the next one, then 2 episodes from now or something like that, we might come back to the same topic, because there's a lot of things to actually explore here. We might look at the actual tools that you use for this, give you some examples of how to do this. And just from the top of my head, if you guys want to try this and to see how DevOps works in practice, take a look at Open Nebula. It's a platform where you can spin up containers and VMs and do that basically automatically. Try setting one instance up for you and run some tests, see how it works out. Try giving access to somebody else so that there's more than one person accessing the system, and you see how it plays out. And you'll see the levels of interaction that you can give somebody else, for example, a developer, and how you prepare the system for that developer to use it, and to give him permission to spin up containers and take them down and all that.
Yep. And some cloud providers have like a free trial to get started out there. So you can just have a look around. There's a bunch of these.
Yeah.
The only thing I'd say, though, is make darn sure you delete everything when you're done trialing it, or you will get a bill. So you make sure you spin up a server. You could play around with it, learn. Make sure when you're done, you delete the server, delete the disk, delete the images, delete the snapshots, delete the DNS entry, whatever you've created. Just write down a list of the things you create as you create it, so you know exactly what to destroy when you're done. You can go on one cloud provider, 30-day trial, learn, practice, close the account, then go on another platform, learn that one, play with it, close the account. And, that gives you a couple of months there to kind of get the stuff down. That's one of the tricks to learning it. And some training platforms out there have labs that you can download and go through too. So there's a lot of content out there, and we'll definitely be covering more of this for sure.
Yeah, absolutely.
All right. So I think that is our episode. So I would say the takeaway from this episode is understanding what DevOps is. And I would encourage everyone in the audience who doesn't already know about this kind of thing to just maybe not learn in depth yet, but just learn what configuration management utilities there are out there, in provisioning tools and things. Not like learn them, but just know what they are, what the goal is they try to solve, how they fit into the ecosystem. Keep it simple at this point, just the high level overview of everything. And then as we go through other episodes down the line, we'll just go through some of these concepts in greater detail. So that'll mean you're right where you need to be by the time we get to that.
Yeah, and you'll quickly realize there are tons of these types of tools out there. You won't have to know all of them, but try to find some workflow and get to know the tools in that workflow, and that will get you up to speed. Because then the high level concepts will apply from one to the other, even if the syntax is not exactly the same. It should be minimally different. So what you learn on one will help you on the others.
I'm so glad you mentioned that, because that's a very big question. Like, how do you, like, people ask me, how do you memorize all this? I don't.
Yeah.
I don't. I just don't. I use the stuff that are the features that are important to what I'm doing. But some people make the mistake of like learning the cloud provider, like all like backwards and forwards, every single feature. Unless you're trying to get certified, I don't really see a reason to do that. For example, if you're not putting out multimedia content, then a CDN, content delivery network, is probably not something you'll need to learn. AWS itself has like 50, 60 different things, and you'll never learn them all. So just learn the things that are important to you in your use case, and focus only on those things. Otherwise, it's overwhelming. You will never learn everything. Do not try this. I practice Linux stuff for a living and teach people everything. And even I don't have everything memorized. So that's just not going to happen.
Yeah, and we live in a time where you don't need to have encyclopedic knowledge of all the aspects of computing. Basically, when we started doing IT many years ago, even then it would be hard to grasp all the concepts and know everything. And right now it's impossible. Nobody will know all the concepts. Nobody will know all the tools, because they keep appearing every new day. It has new tools coming up. Don't even try to. You'll just get frustrated. But do try to understand the high-level concepts. Try to understand how containers work, how they are different from virtual machines, how they are how they are just processes that are restricted in some way and not a full virtualized environment. That will help you on any container platform. When you realize that they're all basically the same, it's all just a question of asking Google what's the right syntax to do whatever you want to do on that particular platform. And Google knows everything, so that you don't have to.
To a fault. But no, that's so true. And just above all else, have fun. Like don't overwhelm yourself. Just have fun with it. Learn it. Just focus on the fun aspect, and that'll carry you through. And if you ever get frustrated, there's not a single person on this planet that I know of or have ever heard of that wasn't frustrated along the way. I was. There's a lot of swear words I say off camera when things don't work that nobody's ever heard me say before. When I get frustrated, it happens to everybody. So, but we'll get there. And today's episode, we talk about DevOps as an overview. That's why. So that gets the conversation started. It gets people on the right track to start researching the individual components of it. And then we'll come right back to this in a future episode. We don't know which number yet, but we'll cover additional things that are within the umbrella.
Absolutely.
Awesome. So that was episode 9. Thank you guys for listening, watching, however you guys digest the content. We really appreciate that. And we'll be back again in a week with another episode.
Yeah. Thanks, everybody. Until the next one.
See you later.